So the next area that we want to talk about are how we make measurements in the laboratory. And so this is going to require that we're able to define what a physical quantity is. And so we have a lot of different terms that we can use to define these physical quantities. So these could be things like mass, volume, the temperature, the density, and other physical properties are called physical quantities. And so they're described by both a number and a unit. So anytime you're making a measurement in the lab, you have to include the measurement number that you make, and you also have to describe the unit that you're measuring in so that you give an accurate description. If you don't have the units present, you will get marked off in the class, because if you tell me that something weighs 32, I don't know what that means. Do you mean kilograms? Do you mean pounds? Do you mean tons? It makes a difference what unit that you have attached to that number. So you have to make sure that the unit is included with that quantity. So a physical quantity then is a physical property that can be measured about a substance. The unit then is defined quantity that's used as the standard of measurement. And we're going to talk about the different units that are commonly used within the laboratory. Mostly the metric system is going to be used to define our common units for things like mass, volume, temperature, length, and time. So again, our physical quantities require a number and the unit that goes along with it. So scientists have agreed to the International System of Units, which is abbreviated the SI units. So the SI standard units are going to be the kilogram for mass, the meter for length, the volume is measured in cubic meters or m cubed, temperature is measured in kelvins, and time is measured in seconds. And so we'll see how these units compare to the metric system, which is just a little bit different than the SI units. And we'll also talk about different units of measuring temperature. So the metric unit of mass then is the gram rather than the kilogram. So they're related to the metric units with a few differences. The metric unit for volume is also called the liter rather than the cubic meter, which is the cubic meter is the definition for the SI units. So for equivalencies, 1 liter is equal to 1/1000th of a cubic meter. So we'll talk about exactly what this means here when we start looking at what volume means. And then the metric unit of temperature is the Celsius degree rather than the Kelvin temperature. So these are just a few differences between the SI units and the metric units. So this is a table then that compares the major quantity that's being measured for a substance and the SI units compared to the metric units. And then it gives their equivalents as well so that you could calculate one from the other. So if you knew the liters, you could calculate the cubic meters. Or if you know the kilograms, you could calculate the grams in the metric unit. So the metric system is actually a very useful system, and we use this to a large extent when we're working with scientific numbers. And this is because scientists work with both very large and very small numbers depending upon what we're doing. When we're talking about single atoms, for example, we're talking about very, very, very small numbers. So, or if we're talking about the number of atoms that actually fill a teaspoon, that could be a huge number. We might have very, very, very big numbers when we're thinking in that scale. So we have prefixes within the metric system that are applied to our units to make saying and writing the measurements much easier to do. So for example, the prefix pico means a trillionth of. So if we're talking about the radius of a lithium atom, which is very, very, very tiny, you could say it's 0.0000000000152 meters. I can't even say how far that is out. I know this is the tenths, the hundredths, the thousandths position, the 10,000ths, 100,000ths. You know, it gets out way far, and it gets really, really difficult to say because that number is so, so small. So it's 152 trillionths of a meter. That's a terrible number to have to say. But if we convert this to picometers, we can convert this and say the radius of the lithium atom is 152 picometers. It makes it a lot easier to talk about, to have these prefixes. So this is the table that is presented in your textbook, and it describes the metric system and their units, and what the base unit is actually multiplied to get to these different units. But I don't like this table very well. I think it's difficult to actually look at this and to understand the changes that are going on. Essentially, the base unit is placed right in between here, between the deci and the deca prefixes. And if you go down, these are all smaller units. And these are all larger units, measuring larger amounts of things more conveniently. So I'm going to give you a different table that I think works better when we're thinking about the conversions between these different symbols. However, you'll notice that there's 1, 2, 3, 4, 5 different ones that are outlined in blue in this table. You guys are required to know how these vary from the base unit, and you're going to need to be able to calculate between these different amounts. So they're the most common ones that you're going to run into. So like if the base unit is mass, that's going to be measured in grams, right? So you can have grams would be our base unit, and it would be the 0 unit here. If we change them to kilograms or to centigrams or milligrams or micrograms or nanograms, what do these different conversion factors mean in relation to our base unit? So you will need to know those. And so I will give you a different table that has the conversion factors between these two based on how many of these different things are in the base unit. Because I think this table here with the extrapolation to the base unit this way, it's nice and convenient for the table, but I think it's confusing. I mean, this essentially says that there's 1/1000th of a gram in a milligram. And I think it's easier to say that there's 1,000 milligrams in 1 gram, rather than there's 1/1000th of a gram in a milligram. So I think we'll write it kind of in the opposite way to make it a little bit easier to deal with. Okay, so I like looking at the metric system with these kind of conversions. So stating that there's 1,000 grams in a kilogram, 100 centigrams in a gram, or 1,000 milligrams in a gram. And then for even smaller units, I tend to relate them to the next smallest unit. And you'll notice a common theme with the metric system is that it's typically based on orders of magnitude of 1,000-fold. So for the smaller units, there's 1,000 micrograms in a milligram. And then if we go smaller to the nanogram level, there's 1,000 nanograms inside 1 microgram. So we can easily use these conversion factors to exchange between any of these unit sizes. And we'll have a little bit of practice doing that. So this is looking at the mass scale. So in the mass scale, we're looking at grams. In the volume scale, we're looking at the liters being the base unit. But the prefixes always stay the same. So when we're converting between the base unit and kilo, then it's going to be on the order of 1,000. So there's 1,000 liters in 1 kiloliter, 100 centiliters in 1 liter, or 1,000 milliliters in 1 liter. And then again, for the smaller units, I relate them to the next smallest unit typically. So there's 1,000 microliters in 1 milliliter, and 1,000 nanoliters in 1 microliter. And again, I think this makes it more friendly to utilize the conversions within the metric system. And then finally, for our unit of length, we're measuring on the scale of the meter as the base unit. And again, the same conversion factors are going to hold within this. So there's 1,000 meters in 1 kilometer, 100 centimeters in 1 meter, 1,000 millimeters in 1 meter, and then again for the smaller units, there's 1,000 micrometers in 1 millimeter, and 1,000 nanometers in 1 micrometer. So when we measure mass, we have to compare two different things. There's looking at the actual mass of an object is going to be the measure of the amount of matter that is inside the object. So mass does not depend on the location of the object. Weight, however, is a measure of the gravitational force that's acting on an object. So the weight of an object is going to depend on its location. So on the Earth, for example, if you're closer to the center of the Earth, there is greater gravitational force, and so the weight of the object will be more than if you're farther away from the center of the Earth. So if we were down in Death Valley, which is at about minus 300 feet below sea level, we would weigh more than we would on the top of Mount Everest, which is very high and farther away from the center of the Earth. So the mass doesn't change, though. We still have the same amount of matter that we're composed of, but our weight is going to vary depending upon the pull of the gravitational force. So within the lab, our scale actually responds to weight. So we're not actually measuring the mass of objects when we weigh them inside the lab. However, we typically will utilize the weight as being equivalent to the mass of the object. If we were at some place that was very far away from sea level on the Earth, we would actually have to correct for the gravitational force of the Earth when we were measuring our mass. But because we're so close to sea level, we can get away with estimating and saying that the weight is going to be very, very close to the actual mass of the compound that's there. So we have different types of balances in the lab. This is a little bit old-fashioned. Our balances look a little bit more like this, and you'll get to utilize these inside the lab. And then, of course, we can confound things further. We not only have the SI units and the metric system, but we also have the English system, which the United States still utilizes. So it's also important that we can convert between our common units that you would see in the grocery store or at the gas station, and be able to convert these with the metric system that we utilize predominantly in the scientific world. So you will be given this conversion chart. You don't have to memorize the conversions between grams and pounds or kilograms and pounds. You'll be given the English to metric conversions on the exams. So within the physical quantities and being able to measure physical quantities, we have a few derived units that we can typically calculate for major compounds or for the movement of objects. And so speed would be one of these things. This is a derived unit, meaning that we have to do some sort of mathematical equation to get the number. And in this case, we're going to be dividing the length that the unit is traveling and divide that per time. So if we wanted to find out how fast our car was going, for example, we usually record this in the United States as miles per hour. So we might say we're going 65 miles per hour. In terms of something that might be going on within the lab, like if we were measuring little rockets that you're going to make, we could calculate the speed of those rockets. We would say how many meters per second do they move. So speed is something that is a derived unit. Density is another derived unit, and so we have to do division to get this unit as well. This is going to be a measure of mass over volume. And so this is going to give us an idea of how compact an object is and how heavy it is. So in this case, it's grams per cubic centimeter. And so the cubic centimeter is used as the SI standard unit. But we know that 1 cubic centimeter is also actually equivalent to 1 milliliter. So we talked about measuring mass. When we measure length, our standard unit is the meter. And then the standard unit for volume in the SI units is the cubic meter, but this is so large that the liter becomes much more commonly used. So 1 liter is equivalent to 0.001 meters cubed, or 1 decimeter. And so this table here is giving our length conversions for our common English units as well. And then our units for volume is the meter cubed for the SI units, and this is equivalent to 1,000 liters. And so this is a nice chart here to look at the volumes. And so the volume is the actual space that's being taken up, and you can see it's a cubed number because for any volumetric measurement, you're measuring 3 sides of the object. So you've got a height, you've got a depth, and you've got the width to consider when you're measuring. And so this would be a representative of a meter cubed. And what we see when we break this down into the centimeter, we can see that 1 centimeter cubed is also equivalent to 1 milliliter. And I think this is the actual unit that is the most valuable to remember. So on a lot of like doctor shows, you'll see them say, oh, give him 1 cc of epi quick to save him, his heart's going bad or something. And so they use this term cc a lot, and that means cubic centimeter. So instead of saying cm cubed, they say cubic centimeter, cc, 1 cc. So 1 cc is actually equivalent to 1 milliliter in the volume. And so you guys will be measuring in the milliliters. Your standard equipment that you'll be issued in the lab will measure in either milliliters or in liter volumes. All right, so what I want to do right now is to go through a couple of different conversions. And so we're going to start, and we're going to just give us an arbitrary number. I'm going to say that we're going to start with 150 meters. Okay, so we're just going to start with a length, and I want to do a couple conversions. The first conversion is I want to change this to kilometers. So we know the conversion. Based on our chart from before, we know that there are 1,000 meters in 1 kilometer. So that is by our definition. So when we have these conversion factors, we can write them as an equivalent to 1 because they're essentially the same thing. If I walk 1,000 meters, I have walked 1 kilometer. They are equivalent to each other, or they're equal to 1. So if I divide them by each other, it's like saying that it's equivalent to 1, right? So if I said 1,000 meters divided by 1 kilometer, it's dividing the same distance by itself. This is going to be equivalent to 1. And we can write that either way. We can put 1,000 meters on top, or we can put the kilometers on top. It doesn't matter. So we can write this one this way as well. Over 1,000 meters. This is also going to be equivalent to 1. So these guys can be utilized then as conversion factors. So this guy and this guy are conversion factors. We have other conversion factors that we can use to go from both the metric system to the English units as well. So we could also say that we know that 1 kilometer is equivalent to 0.6214 miles. So that's another conversion factor that we can use, and we can write it in the same way that we wrote this one. We can say 1 kilometer over 0.6214 miles equals 1. So, and that's going to be equivalent because if I walk 0.6214 miles, that's equivalent to 1 kilometer. They're the same distance. So we can utilize these guys as conversion factors so that we can change our 150 meters into these other units. So if I start with 150 meters and I multiply this by the conversion factor with kilometers on top and meters on the bottom, I'm going to put 1 kilometer up here over 1,000 meters. We can see that when we do this, we can cancel our units out. So in this case, our meters are going to cancel out, and we're going to be left with kilometers in the denominator. So we're going to divide by 1,000 here, so that's going to set our decimal place back 3 places. So this is going to be 0.150 kilometers. 150 meters is equivalent to saying 0.150 kilometers. We can also convert this then into miles, because we can write this conversion factor as 0.6214 miles, or we can write it with the miles on top, 0.6214 miles over 1 kilometer. So if we want to convert this from kilometers into miles, we're going to want to have miles on top and kilometers on the bottom so that the kilometers will cancel out, and we'll be left with our answer in miles. So again, anytime you're doing these conversions, it's very important to write the units out so that you make sure that you have the correct units in the right place. So let's do this conversion then so that we can get this into miles. So we're going to say 0.150 kilometers, and we're going to convert this into miles. So we need to use this form of our conversion factor with the miles on top and the kilometers on the bottom. So we're going to times this times 0.6214 miles over 1 kilometer. So again, the kilometers are going to cancel out. Got kilometers canceling and canceling. We're going to be left with our answer in miles. So if we multiply this, put it in our calculator, we should get that this equals 0.093 miles. So we now know that 150 meters equals 0.150 kilometers, and that's also equal to 0.093 miles. So these are all three different ways of saying that same number. So if I walk 150 meters, I've also walked 0.150 kilometers, and I've also walked 0.093 miles. So this is the way we can use all of these conversion factors by setting them equal to 1 so that we can interconvert between these different units.